Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, we meet again, and this video we are almost at the end of what we call a discussion of our lecture topic 4, matrices and system of linear equation. As you see on the screen here now, is we are focusing on 4.3 inverse matrices, solving using elementary row operation, and 4.4 system of linear equations with 3 variables. Okay, before we continue, I do hope that all of you willing to support my channel by click to the share, subscribe, like and share button, and also notification, so you can get a latest video or new videos in the future. Okay. So, please refer to your lecture notes. And now we are going to apply the elementary row operation, or we short this as an ERO, okay, elementary row operation, to obtain the inverse of 2 times 2 and 3 times 3 matrices. Okay. We're going to write the matrices in a system of linear equation in the form of AX plus B and solve the unique solution of this using inverse matrices or elimination method, Gauss-Jordan. Okay. And find inverse using elementary row operation using ERO. And as you see here now, at beginning, we be given to you a matrices of A, and we combine with a matrices of identity next to each other. So we call this an augmented matrix, and we're going to repeat the process of ERO. We're going to repeat the process with a different instruction until, okay, the position of identity or identity for matrices of 3 times 3 with the matrices, or we call the element inside, which is 1 0 0 0 1 0 0 0 1. So this is a matrix of identity of the size of 3 times 3. Okay, so as you see here now, the matrix of A on the left side and identity on the other right side, and finally we will find that the identity will take place on the left side, and there will be a new matrices appear on the other side. So this is the inverse of the matrix of A. Okay. Now, elementary row operation come up with a few instruction. Okay. Okay, class. When given to you one matrix of 3 times 3, okay, there is no specific one instruction or one specific steps to solve this. The question that involved with the elementary row operation. There are many kind of idea or steps that we needed to solve this. And even though you see on the screen here now, there are instructions that allow, which is interchanging the ith row and the jth row, multiplying the ith row with a non-zero constant. And this one, I found that in some videos in YouTube videos, specifically on these steps, okay, present by many lecturers around the world. Sometimes they come up with the other steps, that which is not only referring to these 3 steps only, but then the idea is we are going to, okay, using the the instruction as you see here now, and finally the goal is to change the position of I from right side to the left side, and we're gonna get a new matrices on the right side. Okay, that we're gonna get the inverse for the matrix of A. Okay, so you see these three what we call instruction here now, and we'll see how we're gonna use that. Okay, find inverse of matrix of A by using elementary row operation. Okay. So class, just imagine that, okay, we got 2, 5, 1, 3 and 1, 0, 0, 1. Okay, class, 1, 0, 0, 1. This is our reference. Okay, so what's the question just now? Find the inverse matrix of A. Find the inverse. Okay, first, class, as I said, that there is no one specific method or steps. Okay, for some of and let's say when a different person get these questions here, okay, might be one person A. Okay, the person A, he we would like to get a new element in this first row. Okay, targeting this one here, the new R1 is 1 over 2 multiplied with R1. Why? 1 over 2 multiplied with 2. It gives you 1. Am I right? So then this 5 here come up with 5 over 2. 1 multiplied with half. 1 over 2 and 0 times half is 0. So the instruction is just for row number 1. So what about row number 2? Nothing changed. So we just rewrite, okay, 3, 0, 1. Okay. Okay. The first person, A, he might might using this, we call this instruction to get the 1 here, because 1 here. Okay. And let's say second person B, okay, second person B, he might think that he may come up with this idea. Interchange between row number 1 and row number 2. Why? Because there's already 1 here. So then he come up with 1, 3, 0, 1 and 2, 5, 1, 0. And again, the first numbers or element in the first row, we call first row and first column here is 1. We still get that 1 here. Am I right? So as I said that for elementary row operation, there is no one specific answers or method only, or steps. Okay, so it might be come up with a different instruction or different idea. Finally, the goal is we like to get the identity on the left side and the new matrices, which is inverse of A, on the right side. That's all. Okay, so okay, so to me, I'm gonna stick with this one here. Never mind. Okay, so we got 1, 3, 0, 1 and 2, 5, 1, 0. Okay, so our first target to get 1 in the first column or row number 1 here, has achieved. Now I like to get a 0 here from this number 2. So we come up with a new row, we call now row 2 that we're going to get after this. We call referring to the instruction of, okay, 2R1, negative 2R1 plus R2. Okay, let's see. Negative 2. And then R1. What is the element of the current R1? the latest one, R1 here is 1, right? Okay, negative 2 R1, which is 1, and plus with R2, plus with here 2. So then negative 2 plus 2 equal to 0. That's it. 1, 3, 0, 1, and 0 here. So when we come up with one instruction for 1 here, for one specific numbers here, so what's going to happen to the rest of it? Just follow the instruction. That's all. Okay. So negative 2 times 5 equal to negative 10. Okay, negative 2 times 5 equal to negative 10, and plus, no, sorry, not negative 10. Negative 2 times R1, negative 2 times 3 equal to negative 6, plus with R2, which is 5. So negative 6 plus 5, negative 1. Okay, and then negative 2 times R1, negative 2 times 0 equal to 0, plus 1 equal to 1. Negative 2 times R1, negative 2 times 1 here equal to negative 2, plus 0 equal to negative 2. Okay, so then I want this 3 here. Okay, for this over 0 here, we already get it, so we achieve it. Okay, now we like to change this 3 into 0. So the new the new R1, which is 3R2, okay, 3R2 plus R1. Okay, let's double check. 3 times with R2. The current R2 here now is negative 1. So 3 times negative 1. And then plus with R1. Well, look at here. 3, right? So 3 times negative 1 equal to negative 3 plus 3 equal to 0. Okay. So then the instruction to get a new R1, row number 1. So then row number 2, nothing happened. We just copy it all again. 0, negative 1, 1, negative 2. Okay, now 3, as we agreed just now, 3 times negative 1 equal to negative 3 plus 3 equal to 0. 3 times R2, 3 times 0 equal to 0 plus 1 equal to 1. 3 times 1 equal to 3 plus 0 equal to 3. And 3 times negative 2 equal to negative 6 plus 1 equal to negative 5. Okay, which I think that this is the one here. So R2, the new R2 equal to negative 1 multiplied with R2. So negative 1 multiplied with negative 1 equal to 1. Okay, so then here we got 0, 1. Okay, because the recall instruction is only for R2, so nothing changed in nothing happened in R1. We just copy it all again. 3, negative 5. So negative 1 times 0 equal to 0. Negative 1 times negative 1, 1. 1 times negative 1, negative 1. And then negative 1 times negative 2 equal to 2. Okay, so guys, girls, what you see here now? This is an identity, and this is the new matrices, which is inverse of the matrix of A. So then A inverse equal to 3, negative 5, negative 1, 2. Okay. Next, find the inverse of P using elementary row operation. So we come up with now it's time for matrix of 3 times 3. Okay. So this is it. 2, 1, 1, 1, 1, 1. Okay. 2, 1, 1, 1, 1, 1, 1, 1, 1, and 2, 2, 1, 2, 2, 1. So what's the question just now? Find the inverse. Okay, find the inverse. So I'm going to combine this with the matrix of identity. So it's an augmented matrix 1 0 0 0 1 0 0 0 1. Okay, now the same process, and I may call class. If you try the same question with your friends, it might be that your steps from the beginning until the end not 100% as same as your friends, because we call during your trying to solve it, might be you have a different idea for some as one situation. You think that you're going to interchange the row and column, but your friends prefer to make operation between that row with other row. But then make sure that the step is correct. We call the addition and subtraction or multiplication is correct. And finally, all of you should get one correct answer. That's all. Okay. Now, this is our reference 1 0 0 0 1 0 0 0 1. So this is our reference now. Okay. Luckily, it gave you 1 here. So which I think that I'm going to make a switch the position between row number 2 with row number 1. Okay. Interchange between row 2 swap with row number 1. Okay. So we got this one here 1 1 1 0 1 0. Then 2 1 1 1 0 0 and 2 2 1. Okay, 2 2 1 0 0 1. Okay. And now, class, I like to change these two. Turn these two into, okay, first of all, we already get 1 here. So, achieve. The goal achieved. Now, we're going to try to get these two, 0, here at same time, at one time. Okay. So, what we're going to do now here is to get a new row of R2. We are going to come up with negative 2R1 plus R2. And the new R3 is negative 2R1 plus R3. Okay, let's double check. Negative 2 times R1. What is the element in row number 1? Here, 1. Okay, so negative 2 times R1, 1 here, plus with R2. And the element in R2, which is 2 here. So negative 2 plus 2 equal to 0. Okay, same thing goes to this one here, because 2 and 1, which I think we're going to use the same instruction here, only with R1 and R3, and this one is R1 with R2. So we're going to rewrite all this. There's only changes in R2 and R3. Nothing happened in a change in R1. So then 1, 1, 1. So 0, 1, 0. Okay. 0 and 0. So the rest of it, we just follow the instruction here. Negative 2. Negative 2 times 1 equal to negative 2. Okay. And then, negative 2 times R1. Negative 2 times 1 equal to negative 2. Negative 2 plus 1. Negative 2 plus 1. Negative 1. Negative 2 times R1 here equal to negative 2 plus R1 equal to negative 1. Negative 2 times 0, 0 plus 1 is 1. Negative 2 times 1 equal to negative 2 plus 0, negative 2 and 0, 0, 0. Then negative 2 times R1, negative 2. Negative 2 plus 2 equal to 0. Okay, luckily. It's not, okay, just now we're focusing on these two to get these two zeros achieved. But luckily, we get extra 0 from one instruction here. Another 0. So it's okay. Okay, so luckily we get 3 zeros at the same time, hat trick. Okay, so then, and -2 times R1, -2 times 1 equal to -2. -2 plus 1 equal to -1. -2 times R1, 0 plus 0 equal to 0. -2 times 1, -2 plus 0, -2. And -2 times 0, 0 plus 1 equal to 1. Okay, next, let's focus on this. Okay, focusing on this one here. If I make a instruction, this one with element in row number 1, make sure that this will not change this, okay, element 1 into a other numbers beside 1. Make sure that it stick with 1. Okay, so then the new R2, if I make this one with this, which I think is easier, right? Because between 0 and 0, it won't change this one. So the new, okay, negative R3 plus R2. Okay, double check. -1. -1 multiplied with R3. What is the element in R3 here? -1. And then plus with R2. -1. Plus with -1. -1 times -1, 1. 1 plus -1, 1 minus 1 equal to 0. That's it. Okay. So then, this instruction for row number 2, so nothing changed in row 1 and row 3, so we rewrite 1, 1. I'm sorry. Okay, 0, 1, 0, 0, 0, -1, 0, -2, 1. So then, -1 times R3, -1 times -1 equal to 1. And then plus with R2, -1, 0. Okay, then, what about this one? -1 times R3, -1 times 0 equal to 0. Plus with -1, -1. 0 is 0, 0. -1 times R3, -1 times 0, 0 plus 1 equal to 1. -1 times -2. -1 times -2 equal to 2. 2 plus -2, 0. And -1 times 1, -1 plus with 0, -1. There you go. Okay, now, okay, this 0 achieved. Okay, so let's focus on this one here now. Okay, this one here, the new R1. Okay, so R3 plus R1. -1 plus 1, 0. 0 plus 1, 1. Okay, that's it. So this is what we call instruction for row number 1. So we just rewrite element in row 2 and row 3. One, 0, 0, -2, -1, and 1. Okay, so R1, which is R3 plus R1. 0 plus 1, 1. 0 plus 1, 1. -1 plus 1, 0. 0 plus 0, 0. -2 plus 1, -1. And 1 plus 0, 1. Okay, now class, this one, the goal achieved. And let's take a look at this one here now. This one. So the new R1, which is the instruction R2 plus R1, -1 plus 1. R2 plus R1. Okay, so what we get here, R2, -1. -1 plus 1, that's it, 0. So then, is also instruction for row number 1. So nothing changed in row 2 and row 3. 0, 0, negative 1, 0, 0, negative 1, 1, 0, 0, negative 2, negative 1, 1. Okay, R2 plus R1. 2, 1, R2 here, negative 1. Negative 1 plus 1, 0. 0 plus 0, 0. 0 plus 1, 1. Okay, 1 plus 0, 1. 0 plus negative 1, negative 1. Negative 1 plus 1, 0. Okay, class. We almost at the end of the solution for this question here now, which I think that we need only 2 more instructions. But then I can put them all together at one step here. Okay, so now we are going to change this from negative 1, turn it into 1, and also this one here. So then the new R2 multiplied with negative 1 multiplied with R2, and the new R3, which is negative 1 multiplied with R3. So nothing changed in row number 1. 1, 0, 0. Okay, 1, negative 1, 0, 1, negative 1, 0. Okay, negative 1 times 0. Nothing happened. Okay, 0, 0. Negative 1, negative 1 times negative 1, 1. 0 times negative 1, 0. 1 times negative 1, negative 1. 0, negative 1 times negative 1 equal to 1. And then 0, 1. 0, negative 2 times negative 1, 2. And 1 times negative 1, negative 1. So, class, what you can see here now, this is the identity, right? 1, 0, 0, 0, 1, 0, 0, 0, 1. And look at this one here now. This is our new matrix that we find from all these steps. And finally, we come up with the conclusion that the A inverse equal to 1, negative 1, 0, negative 1, 0, 1, 0, 2, negative 1. There you go. Okay, you may try yours by yourself, okay, to solve this using ERO. Okay, linear system of matrix equation. So, okay, from these 3 equations, we are going to write in a single matrix equation as this one here. So, A11, A12, A13, we put it all in one. Then, with the matrix of, to represent the x1, x2, and x3, so the x here, and then B. So, we name this one matrix of A, x equal to B. So then, the system linear equations can be written as Ax equal to B. And then, if the numbers of equation, the system linear equal to the number of variables and the coefficient matrix has an inverse, then the system will always have unique solution that can be found using inverse of the coefficient matrices. Okay, to explain this long statement here, okay, we look at this one. Ax equal to B, then x equal to A inverse of B. Okay, I will write this one here. No, we'll explain this on the next slide. Okay, so matrix of Ax equal to B, and as we know that the multiplication between matrix of A and its inverse, or the inverse with the matrix of A, is going to give you an identity. And a matrix of A multiplied with identity, or the identity multiplied with the matrix of A, is going to give you back the matrix of A. Okay, so look at this one here now. the A inverse appear on the left side of the matrix of AX. So A inverse also appear on the left side of the matrix of B. And from here, A inverse multiplied with A equal to an identity here. Okay. And then I identity matrix multiplied with X equal to an X. So that equal to A inverse multiplied with B. Okay, look at this one here. We can find A inverse using a join method and elementary row operation. Okay, a join method, I'll explain to all of you in lecture of part 3, if I'm not mistaken. Please refer to the previous videos. So find inverse using a join method and solve the equation here, class. Okay, so this is a matrix of A. I'm not going to discuss again how to find the inverse using a join by writing it on the screen here now, because we already discussed in part 3 and part 2. So please refer to the previous videos. So just straightly, okay, find the determinant. Okay, in this case, they use the minor and cofactor in row 3, 1, 0, 1, 1, 0, 1. Okay, equal to 1. And find the cofactor, the minor and cofactor 1 by 1. I'm not going to explain it here. You please refer to the previous note and try by yourself. And you should get the cofactor as you see on the screen here now. And transpose the cofactor, that will be the adjoint of the matrix of A. And A inverse equal to this one here, and it's equal to 2, negative 1, negative 2, and all C here. Okay, now AX equal to B, and as we agreed before, that this one X equal to A inverse multiplied with B. Okay, the multiplication of matrix of 3 times 3 with 3 times 1. Okay, so look at this one here now. A matrix of 3 times 3. The column of 3, size of 3, a matrix of A inverse with a row, size of 3 rows in this one here. So finally, it's going to give you a matrix of 3 times 1. Okay. There you go. Okay. As I said that for these videos, I'm specifically, we can discuss a question that to solve the system of linear equation using ERO for a joint. Please refer, all of you, please refer to the previous videos. Okay. X equal to 2, x2 equal to negative 1, and x3 equal to 3. Okay, using Gauss-Jordan elimination method, solving system linear equation. Okay, so you read all this by yourself, because I'm going to be specifically focusing on solving this. Okay, showing on solving this one here. Okay, AX AB, then reduce the augmented matrix. It gives you identity and X. Okay. Now, example 4. Okay. So then, solve this using Gauss-Jordan elimination method. Okay. Now, class. Again, this is our reference. Oh, sorry. Okay. So then, class, this is matrix of A and B, and finally, we must get this identity matrix and the element, the result of this on the right side. So this is an identity. So this is our reference now for the matrix of A. So now the new R2 is the new R2, which is negative R1 plus R2. Negative 1 multiplied with R1, which is 1. So negative 1 multiplied with 1 plus with R2, 1 here. This is negative 1 plus 1 equal to 0. The new R3, okay, so negative 2R1 plus with R3. Negative 2 times R1, negative 2 times 1. And then plus with R3, which is 2. So negative 2 plus 2 equal to 0, that's it. Okay. So it's all instruction for row number 2 and row number 3. Nothing changed in row number 1, so just leave it then. 1, negative 3, 1. Negative 12 and 0. Negative R1. So negative 1 multiplied with negative 3 equal to 3. 3 plus 1 equal to 4. Negative 1 times R1. Here, negative 1 times 1, you can take negative 1. And negative 1 plus 1 equal to 0. Negative 1 times R1. Negative 1 times negative 12 equal to 12. 12 plus 0 equal to 12. Okay. And now, negative 2 times R1. Negative 2 times 1 equal to negative 2. Plus 2 equal to 0. Negative 2 times negative 3 equal to 6. 6 plus negative 1. 6 minus 1 equal to 5. And then negative 2 times 1 equal to negative 2. Plus 1 equal to negative 1. Negative 2 times negative 8 equal to 16. 16 plus negative... Oh, no, sorry. Negative 2 times negative 12 equal to 24. Negative 2 times negative 12. And then plus with R3, which is negative 8. So this is 24, positive. 24 minus 8, 16. Yes. There you go. Okay. Now class, I get this one here, 0, 0. And luckily, okay, I get it 0, 2 here. So I get this one 0, 0, and 0. So we'll see if this 0 can remain until the end without any new instruction. So what I'm going to do here now is I'm going to make this 4, make it into 1. Okay. So the new R2 equal to 1 over 4 multiplied with R2. So 1, negative 3, 1, negative 12. 0, 5, negative 1, 16. 0, 5, negative 1, 16. Okay, R2 is 1 over 4 multiplied with R2. 1 over 4 times 4 equal to 1. Times 0, 0, times 0, 0. 12 times 1 over 4, 1 over 4 times 12. 3. There you go. Okay, so I'm going to change this 5 into 0. The new R3, okay, we are going to make an operation between this 5 with this one here. So then, negative 5 R2 plus R3. Negative 5, negative 5, and R2, at this moment, R2 is 1. And plus with R3, 5. 0. That's it. So 1, negative 3, 1, negative 12. Okay, is instruction for row 3, so nothing changed in row 1 and row 2. 0, 1, 0, 3. Okay, negative 5 times 0, 0. Negative 5. Okay, 0 is 0. Negative 5 times 1 equal to negative 5. plus 5 equal to 0. Negative 5 times R2, 0 here. 0 plus with negative 1, negative 1. Negative 5 times 3, negative 15. Negative 15 plus with R3, 16. Negative 15 plus 16, 1. Okay. So, as you see here now, we already get 1, 2, 3, 4. 1, 2, 3, 4. So, let's focusing on this one here to get 0. Then, the new R1, okay, we're going to make the operation between this one with this negative 1. R1 equal to R3 plus R1. R3, negative 1, and R1 here. So, negative 1 plus 1 equal to 0. So, then 0, 0, 1, 0, 0, negative 1, and then 3, 1. R3 plus R1, negative 1 plus 1, 0. 0 plus negative 3, negative 3, 0 plus 1, 1. And then R3, wait, negative 1 plus 1, yes, okay. 1 plus negative 12, negative 11. Then next is the new R1. Okay, the new R1 here, 3 R2. 3 R2 plus R1. 3 times R2. What is element in R2 here right now? 1. So 3 times 1 plus with R1. Then element in R1? Negative 3. So positive and negative, negative. So 3 minus 3, 0. So then, this is an instruction for row number 1. So row 2 and row 3, nothing changed. So we read out again 0, 1, 0, 0, negative 1. And then 3, 1. Okay. So then R3, R2, 0. Plus 1, 0, 0. 3 times R2, 0. 3 times 0 equal to 0. Plus 1 equal to 1. 3 times 1 equal to 3. Plus negative 3, 0. 3 times 3 equal to 9. 3 times 3 equal to 9. 9 plus negative 11. 9 minus 11, negative 2. Okay. Okay, so one step left. We're almost at the end of the solution here right now. So then the new R3, which is negative 1, multiplied with R3. Okay, so we already got 0, 1, 0, 0, 0, 1, 0, 0, 0, negative 1. That's left here now. So then we get 1, 0, 0, negative 2, 0, 1, 0, 3, okay, 0, 0, 1. So negative 1 times 1, negative 1. Class. So this is it. Okay. So what's the question just now? Solve the following system of linear equation here. Okay. According to this result, so then x, or is it using x, y, z, or x1, x2, and x3? Or x, y, z. Okay. X equal to negative 2, y 3, z negative 1. That's it. Okay. Okay, so exercise. So I leave this all to all of you to try. Class, my idea, okay, as you watched just now, so maybe you can see the ideas from other lecturers or teachers around the world that they share their videos on YouTube. Might be different from mine, but with the same 3 or 4 instruction, okay, and you will get the same, you should get the same result. That's all. Exercise, okay, this answer that you should get. Okay, and this one here, So train yourself. Okay, x1 equal to -1, x2 equal to 4, and x3 equal to 2. Okay, so you may also solve this kind of situation. Okay, so to see how much is the ticket, the price of the per ticket for every single event. Okay. Okay, now class, that's it, the conclusion of the idea for this topic, and I do hope that this video helped you to continue with your exercise, tutorial, and past year questions, and good luck for the test, assignment, and final examination. Okay. So I'm not going to explain everything here because I already explained to you using the example. And that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.